Welcome back, Hononegah Honors Algebra 2. We're continuing with our pre-chapter, our P chapter. P.3, graphing linear equations. Technically, this is going to be just graphing linear equations. We're going to graph linear inequalities. We're also going to graph absolute value equations and inequalities. So here we go. Big thing with graphing linear equations is basically talking about slope and the y-intercept. So if it is in this form, y equals mx plus b form, I would find the slope, I would find the y-intercept. So graphing the y-intercept, the point 0b, and then using the slope to graph the rest of the line. Now, there are other ways to graph a line. You can make an XY chart. You can use a graphing calculator to help you make an XY chart. You can find the x and y intercepts. So again, there's other ways of doing this, but we're going to basically use slope and y-intercept to graph all of these. So adding 2x to both sides. So isolating the y value will allow me to come up with the y-intercept, the 0.04, and the slope. Remember, slope is, from your Algebra 1 days, rise over run. So if you have a slope of 2, you're actually going to go positive 2, positive 1. So let's go over here to the graph the y-intercept, 0, 4, up 2 to the right 1, up 2 to the right 1, so positive 2, positive 1, and there's your line. Domain of all lines, I shouldn't say that, domain of all lines that have slope would be all real numbers. So for domain, you would write all real numbers. To abbreviate that, okay, we would usually say ARN. So again, if you write ARN, I'm going to know that means all real numbers. The range is the the range is the y value. So domain always deals with the x values, range always deals with the y values. So again, all real numbers when you're talking about a linear equation. I'm going to solve this for y, so I'm going to subtract 8x from both sides, and I'm going to subtract 4 from both sides. So negative 2y, negative x minus 4. When you divide both sides or everything in the problem. So 4x plus 2. So now I've got a y-intercept at 0, 2, a slope of 4. So I'm going to go up 4, positive 4, to the right 1, positive 1. So 4 over 1, and I missed that completely, so I'm going to graph that again. So 0, 2. Do a little better job of graphing my line. Domain, all real numbers. Range, all real numbers. And some of you are going to think, well, why wouldn't it be all real numbers? If you had a vertical line, a line straight up and down, then the domain would be that particular value. Same if you had something go straight across, then the range would be that particular value. So there is a possibility, there's two possibilities of not having all real numbers. And there we go. 3x is equal to 15, x is equal to 5. So I'm going to graph the line x equals 5. So that's a line that goes straight up and down at 5. So let's talk about the domain. The domain is just 5. So the x values in the problem is just 5. The range, however, would be all real numbers. Because again, this goes up and down in both directions. So the y values would be 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. So again, all real numbers for your range. Solve this for y. So I notice this is not very conducive to solving this for y. I'm going to add 3y to both sides so the y happens to be on the left. I'm going to subtract 6x so that the x is on the right. This will make more sense to people if you have the y by itself. All right, so let's graph this. Forget about the inequality symbol for just a second. You're going to graph 0, negative 3 with a slope of negative 2. So down 2 to the right 1. So negative 2, positive 1, negative 2, positive 1. You can go positive 2, but then you would have to go negative 1, which is to the left. Now, when graphing an inequality, you always have to worry about dashed or solid. Since there's an equal to line, this would be a solid line. Shading. Now, you can test a point or shade above or below. Since the y value, the positive y value, is greater than, you're talking about values that are above the line. Every point above the line works in this particular question. If you have trouble with this, pick a point and plug it in. So let's say I pick the point 1, 1. If you put 1 in for x and 1 in for y, does it work? Is 6 greater than negative 12, or greater than or equal to negative 12? The answer to that is yes, which is why that side of the line is shaded. So again, you can either think greater than is above and less than is below, or test a point to decide where to shade. Absolute value functions. All right, things get a little bit more interesting with absolute value functions. Is a function that contains an algebraic expression inside the absolute value. The x has to be inside the absolute value. The graph of an absolute value is a v, and the point of that is called the cusp. So now I'm just going to make an xy chart here. The cusp is the value that makes the absolute value portion of the equation equal to 0. So the value that makes that portion is negative 3. Again, you're looking for the value that makes just inside the absolute value equaling 0. So negative 3 is that value. Now pick some other numbers and plug them in for x. So like negative 2 and negative 1, negative 4, negative 5. Let's plug all those in. So if I plug negative 3 in for x, I get 0. I plug negative 2 in for x, I get 1. I plug negative 1 in for x, I get 2. Negative 4 in for x. Now, here's where a lot of people are going to make a mistake. Negative 4 plus 3 is negative 1, but the absolute value of negative 1 is positive 1. Negative 5 plus 3 is negative 2, but the absolute value of that is positive 2. When I graph these points, I will get a V shape, sometimes referred to bouncing. Remember, you're only looking inside the absolute value. So what is the value of x that would make that be 0? Would be just 0. So this is going to bounce at 0. Plug in other numbers. So 1 and 2 and negative 1 and negative 2 would be appropriate. Now, when you plug it in, you have to do the absolute value, then multiply, then add. So let's start in the middle. Absolute value of 0 is 0 times negative 3 is still 0 plus 2. 1, absolute value of 1 is 1 times negative 3 is negative 3 plus 2. Absolute value of 2 is 2 times negative 3 is negative 6 plus 2 would be negative 4. Remember, this is going to bounce. So now, negative 1, and I'm going to show my work on this one. Negative 3 times the absolute value of negative 1 plus 2. The absolute value of negative 1 is 1. Negative 3 times negative 1, or negative 3 times 1 is negative 3, plus 2 is negative 1. Negative 2, absolute value of negative 2 is 2 times negative 3 would be negative 6, plus 2 would be negative 4. So I'm going to graph these points, 0, 2, 1, negative 1, 2, negative 4. Same on the other side. So this makes a V. Now let's talk about domain and range. And we didn't talk about domain and range on the last one. The domain. Domain is always the x values you're allowed to have in the question. In this case, the domain would be all real numbers. The range. Now you'll notice this V goes down and it never goes above a certain point. So the y values would be less than or equal to 2. All the y values in this particular question start at 2 and go less. Remember, whatever x value makes inside the absolute value part equal to 0. So in this case, x is equal to negative 2. That is where your cusp will be located. In your xy chart, negative 2 is where the cusp is. It's the value that makes the x, or the absolute value part, 0. Doesn't matter about the minus 3 outside, just inside the absolute value. So now, pick other numbers. I always go above and below the cusp, and start plugging those in. So I'll give you a few seconds, and then I'll just fill this in. So hit pause if you want. You plug in negative 2, you get negative 3. You plug in negative 1, you get negative 1. You plug in 0, you get 1. Same on the bottom. Plot those points. So negative 2, negative 3, negative 1, negative 1, 0, 1. It makes a V shape. The domain, the x values you're allowed in this question would be all real numbers. The range, notice this goes upward, and the lowest number is negative 3 for y. So all the y values must be greater than or equal to negative 3. Last thing we have to talk about is graphing the absolute value and graphing an inequality. So again, what value makes the absolute value portion 0? It's 1. So the cusp will be located at 1. Pick some other numbers around 1. 0, negative 1, 2, and 3. Take a few seconds and plug those numbers in. All right, so now if I put 1 in, I get 3. I put 0 in, I get 1. I put negative 1 in, I get negative 1. If I plug 2 in, I get 1. If I plug 3 in, I get negative 1. Plotting those points now. 1, 3, 0, 1, negative 1. Now, just like when you graphed inequality lines, if there's an equal to line, it's a solid. If there's not an equal to line, it's a dashed. Shading, just like before. If I'm going to shade less than, I'm going to shade below the picture. If I'm going to go greater than, I'm going to shade above the picture. If you have troubles with that, pick a point, any random point that's not on the V, not on the absolute value, plug it in for X and Y. If it works, shade it. If it doesn't work, don't shade it. Your homework assignment is the P.3 worksheet. If you have questions, please make sure you talk to your teacher, and good luck.